it says like describe this graph, describe this set of data, we are going to use the acronym CUS. So the C stands for center. So we're going to give a measure of center. So either the mean or the median. And I'm going to put or because it can be either or. The second thing that we're going to talk about is an unusual occurrence, which would be any outliers. The first S stands for shape. So I'm going to say whether it's left or right skewed, or I could say that it's symmetrical. And then the last S stands for spread, or I could give the range, I could give the standard deviation, I could give the IQR, any of those three. I usually stick with median and range. Those are kind of my go-tos, but you can choose what is best for you. Which ones you prefer using. There's a difference in how we cuss based on if the data gives me one, like if it only gives me one set of data, or it gives me two and it wants me to compare. So if it just gives me one set, then there's nothing to compare it to. So I'm gonna use numbers. Like the mean is this, the median is, or the range is this. There's no outliers. It's a left skew. But if it's two or more sets of data, we don't need to use any numbers. We have to use comparative language. And by comparative language, I mean like more, less, higher, lower, etc. There are, I don't know how many of them. 6. There are 18 of them. There's also a space like right here. So it's 10,034 and then it goes to 735. So go ahead and put these in your list 1 and get your one variable statistics, like stat calc enter. So we can either use the mean or the median. Doesn't matter which one we use. So I'm just going to go with the median because that's the one I usually go with. So the final thing is that it has to be in context. So I have to refer to what the problem is talking about. I can't just say the median is this, the range is this. It's a left skew, no outliers. I have to actually give some context. So, oops, that's highlighter. So I'm going to say in context. And we've had this problem before. The problem is talking about the damage costs of, or coverage claims of individual vehicles. And so the first sentence is I'm going to talk about the median. So the median, let's see, median cost of collision coverage claims is, what's my median? $1,805. I got something different. Did I type it in wrong?
No, it's 1,000.
Oh, I typed it in wrong. Silly me. Yeah, that's what I got. Okay, so that takes care of my center. The next one is unusual occurrences. How do I know if there's an outlier or not without having to go through the whole process of calculating it? Is there something I could do on my calculator? I could make a box plot. Your calculator should already be set up to have a box plot set. So if you hit zoom 9, you should see a box plot. If not, you can go to second y equals and create the box plot.
Just like do it like CUSS and then like write it out like
you can.
Like bullet point type thing?
You can.
Okay.
Just make sure that they're sentences.
Okay.
And then the last S stands for spread. So I could either give standard deviation, IQR, or range. I normally give the range. So what would the range be on this? If I'm doing max minus min, my max is 21,147 and my min is 180. So if I subtract those, what do I get? 20,100 and what?
967.
Oh, 967. If you gave the standard deviation, that would be fine too. But which one would I use in this case? Would I use the sample one, which is which one?
The S.
Yeah. So if you wanted to use the SX one, 5301.58. Okay, so that is for one set of data. If you wanted to write out the CUSS and then just write a sentence for each, that works too. I just usually make mine into a paragraph form. Okay, so I want you to try number 2 on your own or with your table, and I want you to describe this distribution using CUS. So I said the median score of the first exam was 79.5. If you said the mean, did anybody do the mean? Everybody stuck with the median? I don't know what the mean was. Let me see. If you did the mean, you should have gotten 79. There were no outliers, so when you made the box plot, it should have looked very symmetrical, no outliers.
I saw like a left skew. Yeah. Like the left one was longer.
Slightly. And if you compared the mean and the median, the mean was a little bit below the mean. So if you said left skew, that's okay. But virtually, they're only half a point apart. So it's pretty symmetrical for me. But if you said a slight left skew, that's okay. But like hardly any. And the range of the grades was 32 points. If you did the standard deviation, would you have done the population or the sample in this one? It would be the population one because it's all of the 10 students. So it doesn't just say a sample of them, which would be the 9.818, be the smaller one. All right, so that is whenever you have one set of data. Now we're going to look at when you have two sets of data. So this example talks about students being late to class. So one teacher decided to collect data to determine whether the students' and teachers' watches were displaying the correct time. So at noon, the teacher asked 9 students and 9 teachers to record the times on their watch to the nearest half minute. And if the data was after 12, then it was positive. And if the data was less than 12, it was negative. And if it was completely correct at noon, then it was 0. So comparing students and teachers. And I think the teacher's goal was that the students' watches were slow or the teacher's watches were too fast. So that's something that we could check. So what we want to do first is make parallel box plots using the sets of data. Your calculator will actually make box plots for you and actually stack them for you as well. So what I want you to do is put the students in your list 1, and I want you to put your teachers into list 2. So I'm going to give you guys a minute or so to do that, and then I'm going to explain how to create 2 box plots on one graph. So when you go to plot 2, I want you to hit enter. And basically what you're doing is you're turning the plot 2 on You need to change the type to be a box plot, so the one that looks like this. I think it's like the fourth one.
Does it have the dots or?
Yeah, it should be the one with the dots. It's the fourth one.
I'm just writing down how to use, so it's second.
Yeah, it's on the board right there. Second one goes. And then I want you to change your X list to be L2. So in order to type in L2, you're going to hit second 2. I'm going to make that a comma. So when you hit second 2, the word L or L2 should show up. Once you have that typed in, hit zoom 9. And you should have 2 box plots stacked. You see them? Yes, so whenever you have them both, if you hit the trace button, it'll actually give you the points, like the 5-number summary. And also the point of constructing them up and down is so that you can compare, like they have the same scale. Whereas if you drew them individually, you may not give them the same scale. So the calculator is actually doing that for you. So I'm going to come by and see if everybody had their box plots plotted. Make sure when you make your box plots that you specify which one is students and which one is teacher. So just like label them out to the side. And I tried as closely as I could to align them vertically. So the zeros, these are both zeros. They should kind of stack on top of each other. But if you're drawing it by what you see on the calculator, then that should take care of it.
Pulled strings for this. You cannot do this. No.
My 0.5 kind of went out a little far. I could probably squeeze it right here.
Not much after my hard work to get this.
Speech, but it would be, I would be dropping it anyways.
Okay, so from here, the last thing that we'll do is we're going to cuss comparatively. So I'm going to look at both of the medians, and I'm going to compare them. So did students or teachers have a larger median? Students. So what I'm going to write, and y'all are going to have to help me with this because I'm erasing that, and I'm just going to part B. So the first part of cuss is the center. I'm going to compare the median. So the median time, is that what we're measuring? Time was larger for students than teachers. And maybe the right word isn't larger, but maybe it's faster. So you could put faster too. In the context of the problem, we're talking about watches. So the watches were faster for students than teachers. The second part is outliers or unusual occurrences. Did either box plot have any outliers?
No.
Okay, so I would say there are no outliers for teachers or students. The third one is the S stands for what? Shape. I can't compare shapes, but I can just list off the shape of both of them. So what kind of shape did students have just by looking at the box plot? Right skew? Yeah, I would say I would accept symmetrical or right skew. Because like the range, it goes from 0 to 5 versus 0 to negative 4.5. So I'm going to say, I think it looks more symmetrical. And the teachers looks more right skewed. But if you said right skewed for both of them, that'd be fine.
Wait, doesn't the teachers look left skewed?
Teachers looks left skewed?
Yes.
They're opposites of each other.
The arrows on the
You mean the bottom box plot? That one's definitely a right skew. Yeah, because if you look at the median, if you draw the arrow out to the right versus to the left, it's longer on the right.
Oh, it's from the median.
Yeah,
Oh, is that what you
from the median.
Okay.
I just always look at the lines.
The line is long.
Yeah.
So students had a symmetrical shape and teachers had a right skew. Yeah, because you start from the median and then you draw out. So it would be longer on the right. And then the last thing would be the spread. So if I were to compare the ranges of both of them, which one had a larger range? So student times had a larger range. And you don't have to use larger. You could say teachers had a smaller, the median time was smaller. As long as you're using some form of comparative language, then that's okay. You don't have to say larger every time. I just usually go with that to keep it consistent.